In the annals of human achievement, few endeavors have captured the imagination and defied expectations quite like the Voyager mission. Launched by NASA in the summer of 1977, the Voyager 1 and Voyager 2 spacecraft were the culmination of a bold vision for space exploration, a vision that was about to be realized in the most spectacular fashion. The idea for this mission was born out of a stroke of genius by Gary Flandreau, a brilliant engineer at NASA's Jet Propulsion Laboratory. Using a simple 20th century engineering tool, Flandreau mapped out an ideal route for a probe to reach the distant gas giants of our solar system: Jupiter, Saturn, Uranus, and Neptune. What made this route so extraordinary was that the 4 planets would be aligned in a unique celestial configuration, creating a cosmic necklace that would allow a spacecraft to gain speed by gravitational assist, as if being pulled by an invisible rope. This alignment occurred only once every 176 years, and NASA acted swiftly to take advantage of this rare opportunity. Voyager 1 and Voyager 2 were launched just 15 days apart, and they were tasked with a mission that would normally have taken 30 years to complete. But thanks to the gravitational aids of the cosmic necklace, the journey was reduced to just 12 years. Little did anyone know then that these twin explorers would break all records in the history of space missions, lasting more than 45 years beyond their original lifespan. More than 4 decades after their launch, the Voyager spacecraft are still operational and sending back data daily from the edges of our solar system. They have become the farthest spacecraft in history, having traveled far beyond what was first imagined. They have defied all expectations and continued to expand the boundaries of our knowledge. At the start of their epic journeys, the Voyagers gave us incredible close-up images of the moons of Jupiter and Saturn, revealing worlds far more active and dynamic than had been anticipated. Discoveries of active volcanoes and ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to approach Uranus in 1986 and Neptune in 1989, becoming the only probe to have visited those planets. Surprising scientists with astonishing discoveries in previously unexplored territories, Voyager 2 forever altered our perception of the cosmos. Earth's journey began with a gravity-assisted maneuver around Venus, a feat never before attempted by any spacecraft on its route to Mercury, making them true pioneers. The journey to Jupiter took the spacecraft 10 times the distance from Earth to Mercury and forced them to traverse the dangerous asteroid belt, a feat previously tackled by the Pioneer 10 and 11 probes. But the challenges didn't end there. With just 69 kilobytes of memory, a fraction of the capacity of a modern smartphone, the Voyager's John-board computers had to rely on their own intelligence to manage the complexities of this extraordinary journey. Data collected by the Voyager instruments was stored on 8-track tape recorders before being transmitted to Earth via a transmitter that used just 23 watts, about the same power as a light bulb. The spacecraft were equipped with 12-foot diameter satellite dishes to facilitate communications. They used light-speed radio to send and receive messages, but the increasing distance from Earth, in advance of 3 or 4 light seconds each day, presented major challenges. Despite these obstacles, the Voyagers have defied expectations and continue to amaze astronomers with unexpected discoveries in the interstellar void. Their journey has rewritten our understanding of the cosmos and altered our view of the unknown. Beyond our solar system lies the enigmatic Oort cloud, a vast congregation of comet-like objects held together by the sun's gravity and stretching out to the nearest star. Though the Voyagers are still moving slowly toward that distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. Initially, this boundary was estimated to be about 50 astronomical units, a U from Earth, and so it was decided to continue funding the mission, even as the probes approached that milestone. However, crossing this boundary did not immediately detect a change in the environment, leaving scientists baffled. The passage into interstellar space was expected to be accompanied by an abrupt increase in the number of cosmic rays, high-energy particles traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. However, most of the high-energy rays are deflected by the magnetic shield generated by the heliosphere, which protects our solar system from most external threats. The Voyager mission team also closely monitored any changes in the prevailing magnetic field as the spacecraft moved into the interstellar medium, an environment composed of ionized gases and influenced by nearby stars. This interstellar magnetic field was expected to have a different orientation compared to that of the heliosphere. However, the Voyagers did not detect any significant change in the magnetic field. It was on August 25, 2012, that Voyager 1 finally crossed the heliopause and transmitted fascinating data that confirmed the expected increase in plasma density, although without evidence of a change in the magnetic fields. This puzzling finding generated an intense debate in the scientific community. If the magnetic field did not change significantly when crossing the heliopause, what was this telling us about the nature of the interstellar medium and the interaction of our solar system with its environment? Voyager 1, by entering this new region, known as interstellar space, offered a direct window into a never-before-explored area, but it also raised more questions than it answered. An early theory suggested that the interstellar magnetic field might be aligned in an unexpected way with the solar field, creating a smooth transition rather than an abrupt cutoff. This would imply that the forces shaping our cosmic neighborhood are more complex than we had imagined. The data also revealed a noticeable increase in high-energy cosmic ray particles from outside the solar system, confirming that Voyager 1 had officially left the protective bubble of solar influence known as the heliosphere. What the mystery remained. If there was no marked change in the magnetic field, how far was the probe really from a region completely dominated by the interstellar medium? Some scientists speculated that there might be a more extensive transition zone than anticipated, a region where the effects of the sun still interact subtly with the interstellar environment. Others suggested that the heliopause might not be a clearly defined boundary, but rather a fuzzy border that varies depending on factors such as the solar cycle or the pressure exerted by the interstellar medium. As Voyager 1 continued its journey beyond the heliopause, the data transmitted back to Earth defied long-held assumptions. Analysis of plasma density revealed unexpected fluctuations, hinting that interstellar space was far from the uniform vacuum once imagined. Rather than an endless expanse of homogeneity, this vast frontier appeared to be composed of pockets of plasma, each with distinct densities, temperatures, and energy levels. These findings puzzled scientists. Theoretical models had suggested that the interstellar medium should be relatively even, shaped over eons by the gentle but consistent pressure of stellar winds and cosmic radiation. Yet Voyager 1's instruments painted a different picture. Within a single week of observations, the probe detected shifts in plasma density, suggesting it was navigating through regions of vastly different characteristics, some denser and hotter, others surprisingly sparse and cold. The variations were so stark that researchers began referring to these pockets as plasma clouds. Further study revealed that these clouds seemed to align with traces of ancient supernova remnants, suggesting that the interstellar medium might bear the imprint of catastrophic stellar events from millions of years ago. Each pocket could be a relic, carrying clues about the violent history of our galaxy. In this far-flung corner of the cosmos, Voyager 1 continues its journey, sending back data that will forever change our understanding of the universe. As the spacecraft drifts ever further from Earth, It serves as a testament to human ingenuity and the boundless potential of space exploration. It is a reminder that there is still so much to learn, so much to discover, and so much to understand about the vast, mysterious expanse that lies beyond our planet. And as we gaze upon the stars, we are reminded that we are not alone in the universe, and that the possibilities are endless.